Yes, so hello friends, this is the video tutorial for today's Leetcode problem of the day, which is 1015, smallest integer divisible by k. So what the question says is, given a positive integer k, you need to find the length of the smallest positive integer n such that n is divisible by k and n only contains the digit 1. Return the length of n. If there is no such n, return minus 1. Note n may not fit in 64-bit integer range. So what the question says is, you will find some length. So let's say our length is 5. So what would be our n? N can only contain digit 1. So it would be 1 5 times, right? This number. Now we need the minimum length such that this condition is true, that n mod k is 0. Actually, one more note, that if you are facing problem solving this question, you can try solving yesterday's problem of the day on LeetCode. That is very similar to this problem. So I will continue now. So basically, if we see this problem, what would be your solution? Well, that let's start with length 1. We'll generate our n and we'll check that is this condition true. If this is not true, we'll go to length 2. Then again generate our n. We'll again see what is our value. Okay. Then for 3, and we'll continue till this n mod k is 0. Okay. So couple of problems in this question. First problem is, see, if what happens if length is 20. So our number would be what this one occurring 20 times, which is greater than even 10 is to the 20, right? Because what is 10 is to the 20? This is 1 followed by 20 zeros, right? And this has 1 as a digit. So this will not fit in integer, this will not fit in long, this won't fit in anything, because even the long I think has a constraint of 10 is to the 18. So this cannot fit in anything. So this would go out of bounds. So how can you fix this? Is, see, k is actually, we can see here the k constraint on k is around 10 is to our 5. So rather than keeping a whole n, we can keep n mod k only. Why is this helpful? Because see, n mod k is the remainder when n is divided by k. So the remainder can be from 0 to k minus 1. So that is that this value n mod k would only be between uh, would be less than 1e5, right? And this would never go out of bounds. So, okay, this fixes one problem. So basically, see, what is a conversion? So our new n, we'll say this as new n, is 10n plus 1, right? We are adding one digit at the back. So if the number, let's say, was 1, we basically shift this one here and add one back. So that is the older n value gets multiplied by 10. So we have one empty slot, and in that slot we are adding 1, right? So this is our conversion. Rather than doing this, we'll do the conversion on the in under mod k. So that is new n mod k is basically 10n plus 1 mod k, right? And because see, the value we are interested in this in the new n mod k only, right? We only need to check that is this mod k equal to 0. If it is not, we'll continue our jobs. Okay. So this fixes our out of bound problem. But the other problem that we'll have is, when do we stop? So when do we stop is basically that when should we return minus 1? That we'll accept defeat. We'll say, okay, there is no length for which n is divisible by k, and mod k will is always not equals to 0. Okay, how do you do this? So let's take an example. Let's say n equals to, or rather not n, let's say k equals to 5. Okay, so we'll start with 1, right? We'll start with the length 1, so our number would also be 1. So that is 1 mod 5. So 1 mod 5 is 1, right? Then we'll go to 11. Then we'll go to length equals to 2. Our new number would be, see, the older mod 1 into 10 plus 1, that is would be 11. And well, then we'll do 11 mod 5, we'll say 1. Okay. Then let's go to length 3. Again, we'll do the same thing. The newer n would be 1 into 10 plus 1 equals to 11, and then we'll do 11 mod 5 equals to 1. Okay, we can keep trying, but the thing that you need to actually see is that this n mod k is never changing, it is always 1. So see, let's say that after adding the digit n mod k was earlier x, now it is getting changed to y. That is under this transformation 10n plus 1, this transformation. The n mod k gets changed to from x to y if this y is actually a point that we already visited. So let's say this y is something like this. We already visited this point, that already went to this point, and from this x we are going to this y. Are we forming a loop? Yes, we are forming a loop, and we'll never actually go out of this loop. From this y we'll again do a traversal, and this will again go back to x. So if this y, or this new point, this new n mod k, is something that we have already visited, we should accept defeat. Okay. And otherwise we'll continue it. We'll continue our traversal. And what is the maximum amount of time? And the maximum amount of traversal we'll do, because see, we'll do O of k traversals. Why? Because if at this y point, if it is visited, then we are returning minus 1, right? And this y can be from 0 to k minus 1. So each state is actually getting visited once. If it is visited 2, we are returning minus 1. So that is why we are doing k traversals, and the time complexity becomes O of k. So this is also a time complexity here. So we can now jump to the code. Let me show you how we can implement this also. So okay, let me make this bigger. Yeah. So I just keep this visited array, and this visited would be of size k, because all the visited points can be from 0 to k minus 1. I have this x. This x is basically it would be better to say this as n. Let me also change it then. If visited n, if n. Okay, just give me 1 second. N equals to n mod k. Yeah. So if we are at a point that visited, this point has already been visited, then we have formed a loop. We'll never go out of this loop, and n mod k would never happen, would never be 0. So we'll just return minus 1. Else we'll check if this is divisible by k. If this is divisible, this n is divisible by k, or n mod k becomes 0, then we'll just break, and after breaking we are just returning the length. If it is not, we'll have to add another digit. So we'll mark the current point as visited, and then we'll go to this new point, and this transformation n equals to n into 10 plus 1, and add 1 to length. Okay. So I can submit this, and it will get an accepted solution. Yeah, thanks for watching. If you like this video, subscribe, like it, all of those things. Bye bye. Thanks for watching.